Well, good morning, ETEChians, and to those of you in Mr. Lake's Period 7 class, good afternoon. Today we're going to be beginning our next unit, and we're going to do it with a little intermediate activity. And this activity is going to begin with something that we call the engineering design process. Now, in order to be working on this today, you need to have your notes. You will need to have the graph paper that you should have picked up when you came in the room. There should have been, or either for you to pick up or they need to be handed out now, this little piece of paper, the Ask, Plan, Imagine slip, as I call it, with a piece of tape so you can tape it on your graph paper. And along the sides of your room, by each group, we should have an information taped up there. So what we're going to start with our notes today, we're basically going to draw this diagram right here. And to make sure we have enough time, the engineering design process. This is the scientific method for engineers. And this particular method was kind of worked out with the NASA education resource people. So, to begin with, in the engineering design, every engineer, they're given a task. That's the goal. So let's get the goal written in there. The goal may be to make a really cool action figure that can do stuff, okay? And look, there's engineering here, okay? You got to figure out, okay, what, how much do we want it to move? Okay, there's questions to ask. There's like, what kind of material are we going to make it out of? We have this so that when our administrators ask us if we've seen data, we can say, yeah, we see and we manipulate data every day. If you're not a Star Trek The Next Generation fan, it's Lieutenant Commander Data. Anyway, anything that you use has had an engineer has worked with this, okay? I mean, hey, there's nothing you can find around you that an engineer hasn't worked on. Engineers are important. I hope you become engineers. There's the top of R2-D2. So, the point here is that there is a process with that. Get those. Ouch! Okay, get those over there. Okay, the goal. And the first step in there we're going to put, now let's see, okay, so we got those. Let's put ask. We'll kind of consider that the beginning. Okay, you got to do this. As an engineer, you need to start asking questions. Well, how much does it, okay, you get the idea. Ask. Now, I'm going to draw a little arrow over here, and imagine. Okay, so. Okay, start coming up with ideas. And the crazier the idea, it's okay. Because like, the NASA engineers, when they were designing the Curiosity lander, some ridiculous engineer said, hey, let's have like a bunch of cables that'll lower it, and we'll have rocket motors guiding it, and then we'll cut the cables with explosive bolts, and then the rocket will fly off, and then it'll land safely. It's like, right, how crazy an idea. I mean, it's kind of like this right there. Crazy idea, huh? Except, boy, you could put a nice big motor there, and then, if you, you got a couple of places for pilots to sit. The idea is, ideas, be crazy at first, because crazy ideas can end up working. There's this one crazy idea these two brothers had about 13 years ago. They want to make an airplane, so they could fly. Anyway, imagine. Disneyland does that all the time. They call it Imagineering, and I like that. Next is plan. Okay, you're going to start working on a plan, and that today is what this is for, graph paper, the tool of the engineer. Okay, plan. Okay, now after you got a plan, Stan, you got to create. So we're going to bring this down to here. We got create. We're not creating today. We'll create next time we meet. You will only be able to use materials we provide for our first project here. Then you're going to begin the experiment. That is, after you create your structure, you're going to test it. Experiment. Okay. Ooh, I should have. There we go. Experiment. And then as you experiment, you're going to put it on the floor and you go, oh shoot, the wheel falls over or whatever. Okay. Next thing, you improve. Only one O in improve. I always embarrass myself with that one. Improve. Make it better. And along the process, it's a cycle, okay? Go back and ask. Maybe you see another group that's working. Oh, man, look at that over there. That's a great idea. Let's do that. The Russians did that to us for years because you look at half of their airplanes, it looks like ours. Anyway, engineering design process. So I'm going to give you the goal for our first task here. Now, I'll try to get some of the ask questions out of the way, but, you know, because you need to know that. We can, if you need to, you can ask Mr. Lake. If not, well, we'll just do our best. Then imagine you're going to start talking with your group members. You're going to start throwing out ideas, and then everybody is going to draw their own plan. You can share ideas, but everybody draws their own plan. That is important. Oh, wait a minute. Look at this crazy idea right there. I like that one. Okay, that's kind of cool. You put the, because I thought, seriously, come on. Who wants to be that close to the runway, right? I mean, come on, you want to be a little bit higher. By the way, if you ever see plane crashes, the part that almost always is intact is the tail, okay? So anyway, let's move along. Here we go to the design challenge, DESIGN, challenge. Okay. You are going to design and build a model of a lunar buggy that will carry equipment and astronauts on the surface of the moon, as well as determine the best slope for the ramp. Okay, we're not going to determine the best slope for the ramp. We're going to have a ramp pre-set up, but you're going to calculate the slope and stuff like that of the ramp that we use. So, but that's the main idea here, is that you are going to be designing a lunar buggy. You just saw the Galileo Was Right episode of Earth to the Moon. They were lucky they got to use a lunar rover. It was a lot of fun. But it gave them a great tool because they could cover a great distance. So now, here we go. In detail, the design challenge. Oh, build a lunar buggy. Now, you don't have to write out all these design challenges. Okay, we're going to have them here. But here we go. So here's the goal. This is what you're going to have to build. All right, to begin with, the lunar buggy must carry one plastic egg snugly. The egg may not be taped or glued into place. The egg represents the cargo hold. So with this model that you build, when you build it, if I were to pick it up and turn it upside down, the egg would fall out. Okay, so it has to be it has the potential to fall out if you don't come up with a way to secure it. Hey, don't get mad at me. Okay, this is the design parameters. I didn't come up with it. I'm just the, the tech rep here representing this to you. Number 2, the lunar buggy must be able to roll with a cargo hold containing 10 pennies or 10 washes. Well, we got pennies. So your cargo hold has to hold 10 pennies. Number 3, the lunar buggy must have room for 2 astronauts. You may use plastic people provided. You may make your own. Your astronauts may not be taped or glued in place. Your astronauts have to have the ability that they can easily be taken out. All right? Now, with that, I will provide, Mr. Lake and I will each designate something that will represent as the astronaut. So we'll let you know what that is. And they're whatever they are, okay, they're not going to be much bigger than this R2-D2 top to my flash drive, okay? But anyway. Number 4, the lunar buggy must roll on its own down a ramp with a rise over run of 1/3 for a distance of approximately 100 centimeters. You will have success if your buggy will roll 100 centimeters. That's the target. Just like our Spirit and Curiosity rovers, they were designed to last 90 days. They're going on more than 6 years. Well, one of them is, okay. The other one, it succumbed after 5. But you meet your design goals, and then hopefully they'll go beyond it. Hopefully they'll go quite a bit beyond it. We'll be testing this on a solid, hard surface that's as level as we can get it. Number 5, the lunar buggy must be able to hold cargo and astronauts in place and intact as the buggy rolls down the ramp. So you can't let your astronauts can't bounce out. Your pennies cannot bounce out of the cargo hold. Okay, so you got to design them in such a way that that won't happen. And number 6 over here, your lunar buggy must have a solar panel with wires attached to, quote, the motor unit. We'll be using the same solar panels that we used in the previous activity. Number 7. Now, this is the one that you got to watch out for. Your lunar buggy must survive a 2 decimeter hard surface landing. Here's a meter stick. Here's over here. There's 0. There's 20 centimeters. That is 2 decimeters, okay? Oh, you can't see the whole thing. Okay, it's 20 centimeters. So we're going to hold it up this high and drop it onto a hard surface. It has to survive and be ready to roll. So before you do your final testing, we're going to drop it that distance, make sure it survives. That's going to simulate. Sorry, I got it out of order here. That's to simulate the stresses of takeoff and landing. And when you do this test, the crew and the cargo must not be lost. It has to still be in there. It has to be able to drop. It has to roll down the ramp afterwards, and the cargo and the people stay in. Now, let's see. We're entering into now the ask phase of this. Now, here's some answers that I've got pre-done that some students have asked. And for my period 1 class, I'm gone today. If you need to, you can ask Mr. Lake to come over and ask if there's questions that aren't covered here. So, you may only use materials supplied. I'm going to show them to you in a minute. All materials from the cart must be returned in their original condition. You can't cut them up, break them up, or destroy them. They have to be tape removed and returned so we can recycle these. Now, this must fit within the red cube. This is the red cube of science. I'm going to open this up here. Let me zoom out. So it has to fit inside of this. Oh, you can't see the container. How about over here? If I set it on the floor. Okay, so there's this container right here. It is, I think it's a cube 26 centimeters on a side. So it has to fit inside of, oh, I'm out of the picture, sorry. So it's a cube, figure it out, okay? 26 centimeters, but we'll have it here for you to fit in. The main reason for that is that that's the size of the storage compartments we have in the classroom. The crew must be easily removable. So what that means is you cannot tape or attach the crew in, but, okay, but if you find a way that you can find a way to secure them, as long as it doesn't violate the spirit of the rule, that'll be okay. But if I say, please let me see your astronaut, you need to be able to, oh, well, here's the astronaut. And the astronaut needs to be extractable without like removing tape and stuff, because you can't tape them in. There we go, data. So let me show you the cart. Now I'm going to have to manipulate the dock cam here. Hopefully you got it there. There is the cart. Oh, good. That's kind of coming out pretty good. So we have these materials. And in the materials, I mean, okay, there's a pen. We got, stuff like this. And the cart's in the back. You can take a quick look. No, you can't. There's some paper scraps here. We got some pipettes kind of stuff. Here's some old bottle caps. Okay, there's some foil and stuff. We got various types of foam. We got square foam, rectangular foam. We got little foam pads right here. We've got more stuff. Now, anything on this cart, whoops, you cannot cut or destroy. They have to be returned. Oh, darn it! They need to be returned in the same order we had. Here's some CD cases. Okay, here's some, here's some styrofoam that are wheels. If you want to use those as wheels, cool. Okay, we've got skewers. Okay, wait a minute. There's rocks in here. Those weren't supposed to be there. Let me get. Okay, what geologist? Okay, anyway. Okay, so we got stuff in there. So there's various miscellaneous stuff. Here's little plastic things that you can use. Okay, now you are allowed to, if you need something you've got to cut up, we'll get some cardboard for you. Let's see. In this container here, we'll have this. Put over there. Can you see here? But here we got some larger sized pieces of material. Let me turn on this light real quick. Might help a little bit, have a little more light. And then we got a bunch of junk. I mean, look, here's like old tubes and stuff. Now, straws you can cut up. Paper, if you want to use paper, we'll supply some paper. I mean, okay, we'll have these out. There's a ton of junk in there. Oh yeah, we got like these are like pen caps right here. These are like pens that don't have pens in them, so if you need something like that. Okay, these things right here, so various stuff. Today, you're going to start getting a rough idea. Oh, if you want to use this as the basic body, these are kind of a hard plastic material. You can use those for the body of the vehicle. You're not allowed to cut this up. I mean, some are too big, okay? You need to cut something up, we'll get you cardboard you may use. So let's see. Oh, down here, okay, we got, you know, I mean, there's all sorts of stuff for you to use. You can't bring stuff from home, no cheating. Okay, and you know, okay, straws you can cut up. So you get the idea. We got a miscellaneous junk left over, I mean, here that you can use. So with that, let me come back over here and just come over to this part now. Let me turn off the lights. I think we're getting blinded there. Now, you're going to start talking with your group members. Now, on your graph paper, somewhere, let's get this taped over here. It says, what questions do you have? So if there's any questions that you're having, you know, let's get them written in there. What parts do you need in order to make your buggy roll? We want to get that filled out. What will hold the egg in place? These are questions you need to begin thinking about on your paper. What will hold the astronauts in place? Now, for the technical drawings, we want a top view. We are going to want a side view. And we're going to want a front view. So whatever you're making, keep in mind the size requirements. We need to see the views. Now, I know this is a process of evolving, and on your final project, we'll get these in. But now, today, everybody needs to be making one of these. You can be talking with your group members. You do your idea, and you don't let some idiot come along and go, that's stupid, okay? Hey. Somebody probably said that to the NASA scientists that designed Curiosity. Okay, don't let anybody do that, because there could be genius in their stupidity, okay, so to speak. So you're going to get to work on this the rest of the period. In class next time, we expect to see your top, side, and front view of your project done, and adieu. I got to find the stop button. Hope I didn't forget anything here. So, nope, that's it. You're working on that. Oh, these questions, right, we have them taped by each group. Please leave them up there because we need them for the next couple of days, but they're taped by a group. Goodbye, everybody. Have a great time, and adios.